Hello again. In this video, we're going to talk about describing transformations. And we're going to be given a function with lots of numbers added. We're going to compare it to the parent function and then describe all of the transformations together. All right, so what I've included here, this whole screen of notes, and we've talked about this in the previous two videos. If you're unsure about that, you need to go back and watch the two videos before this, but we're going to jump right into some examples. So for our first example, we're given this function g of x. G of x is equal to 1/2 times the square root of the quantity x minus 3 plus 5. First things first, what is the parent function? So our parent function here, we know we would have a square root graph. This would look like y equals the square root of x, which is half of a parabola pointing off towards the right. All right, so we have these different number values. And I'm going to write a little bit less than I have in previous examples because we should understand these concepts now. We're just looking at applying them all simultaneously. So remember, for each of these numbers, we're going to look at the location and the operation. Let's focus on 1/2 first. 1/2 is on the outside of the grouping mechanism. So it's on the outside vertical and it's multiplied. So it's a shrink, stretch, or flip. We would identify that and call that A. A equals 1/2. So this is going to be a vertical shrink or stretch. Since we are multiplying by a fractional number and it's on the outside, so it behaves as we expect, we know this is going to mean that it shrinks vertically by a factor of 1/2. Next, we will look at this minus 3. So again, focusing on location and operation. The location is that it is inside the square root with the x. Inside lets us know horizontal, and it also lets us know to be on the alert that it's probably going to do the opposite of what we think. And then the fact that it's added or subtracted in this case, but addition is subtraction, so it's added, that lets us know it is a shift. The letter we use here is H. Keeping in mind the standard form is x minus h. This is like saying x minus positive 3. So h is positive 3. That lets us know we are going to shift horizontally 3 units to the right. And then lastly, we have plus 5. So plus 5, this is also added. And again, adding lets us know we have a shift. But because it's on the outside, it's a vertical shift. So k equals 5. It's going to shift horizontally 3 units to the right. And then we're also shifting vertically 5 units up. So my full or my complete sentence, well, it's not really a complete sentence, but my phrase type answer would look like this. If I was trying to apply these values, right, to an ordered pair, well, my x value, if I'm shifting right, that means I would be adding 3 to my x value. And my y value, I'm going to multiply y by 1/2, and then I will add 5 to my y values. So if I was given a point on the parent graph and I wanted to apply that transformation, this ordered pair I've written down at the bottom of the screen, that's going to let you know exactly where the new point, where that transformed point will end up on the new graph. All right, let's do another example. For our second example here, we're given that g of x equals negative 3.2 times the absolute value of the quantity x plus 2.8 minus 1.5. So we have our parent, which lets us know the shape. And the parent graph here is going to be y equals the absolute value of x. And we know, of course, because we know our library of parent functions, that that is shaped like a V opening up with a vertex at the origin. Let's look at each of these values. So we have minus 3.2. We have this plus 2.8. And then we also have this minus 1.5. What do each of these numbers do? So let's look at each individually. Negative 3.2, that's on the outside of my bars. So we know that it's vertical and it's multiplied, which lets me know it's a shrink or a stretch or a flip. In this case, we would say A equals negative 3.2. 2.8, that is added and it's on the inside. Inside lets us know it's horizontal. Adding lets us know it is a shift. H in this situation is the opposite. Horizontal is always the opposite. So H is negative 2.8. And then minus 1.5. That is an addition or subtraction in this situation. So adding and subtracting is a shift. And on the outside, it's a vertical shift. We'll say K is negative 1.5. So if we were describing this using a sentence, we would say that g of x is the shape of y equals the absolute value of x. It is stretched vertically by a factor of 3.2, and then it is reflected down over the x-axis. Then it is shifted left 2.8 units and it's shifted down 1.5 units. All right, so this would be our entire phrasing for how we would answer this. So we know the shape because the absolute value bars let us know it's a V shape. So multiplying on the outside, that lets me know of my vertical shrink or stretch. Since I'm multiplying by a number that's bigger than 1 and I'm on the outside so I behave properly, I know this is going to be a stretch by a factor. We're stretched vertically by a factor of 3.2. All the negative does is tell us that we are reflecting. And if you reflect vertically, that means you go down across the x-axis. And then because we are added on the inside, we're going to shift horizontally and we're going to do the opposite of that. So it looks like you'd go right, but you actually end up shifting left 2.8 units. And then adding on the outside is my vertical shift, and that behaves as we expect. So we're going to go down 1.5 units. If you looked at trying to write a new ordered pair that would give you all of the points from the parent graph transformed onto the new graph, that x value, you would need to subtract 2.8 from it, and then your y value would be multiplied by negative 3.2. So we'd say negative 3.2 times y, and then minus 1.5. So that would be a new ordered pair that would give us any point on the transformed graph if we had known the points on the parent graph. All right, let's just look at one third example of combining all these transformations together. Now, this third example, we have g of x equals 1/3 x minus 1 quantity squared minus 1. This one is a little bit tricky, and I don't test you on anything like this in our algebra class, but you will see this in your upcoming trig classes. So you may have one question like this on the homework, but it's not going to be on your test. That said, I still think it's important to at least show it to you now so it looks familiar when you get to the next class. So in this example, we want to describe the transformation. And of course, we know what our parent graph is going to look like, that x squared graph. So we're going to have y equals x squared. We know the graph is shaped like a parabola. But this problem is different, and this is a unique situation. We have both a c value and an h value. So we have two values inside the parentheses. And when these happen in conjunction, we need to do a slight manipulation before we determine what my horizontal shrinking or stretching will be, as well as my horizontal shift. Obviously, this minus 1 here, that lets us know because it's added on the outside that the graph's going to be shifting down 1 unit. But let's look at this. I'm going to rewrite this, factoring out the c value. So I'm going to factor out 1/3, and that leaves me with x minus 3. All right, so that's kind of the trick when you have two values inside the parenthesis. You want to factor out the c value. So in this case, c equals 1/3. My h value on the inside, h is going to equal positive 3. And then my k value equals negative 1. All right, so like I said, when c and h are both occurring, you always want to factor that c out. See, notice it's still all grouped in my parentheses. So if I were describing my transformation here, we would say, well, it's the shape of the parent, which is y equals x squared. Multiplying by 1/3 lets me know, now that's 1/3 on the inside, so it's a horizontal shrink or stretch. Normally we would say 1/3 of something is less and would indicate shrink. However, because it's on the inside, it behaves the opposite way, and we're going to say it stretches horizontally. So it's going to be by a factor of 3, so it'll be 3 times as wide. So it stretches horizontally by a factor of 3. And then we're going to shift 3 units to the right and 1 unit down. So that would be all of my phrasing for answering this question. We know the shape because we are multiplying on the inside. It's a horizontal shrink or stretch. It behaves the opposite. So 1/3 we'd think smaller. It actually stretches by the reciprocal amount of 3. Looks like it should shift left 3 units, but it actually shifts 3 units to the right. And then the minus 1, we shift down 1 unit. And then including an ordered pair, how does that change my x and y value? I would end up with 3 times x plus 3. And then my y value, we would say y minus 1. That would be my new ordered pair. All right, so I hope that helps you understand these transformations all combined together a little bit more. Again, you're not going to see this double CH situation on a test, but I would generally expect you to know it. And then we talk about this a lot. It's actually called a phase shift when we get to trig. As always, please feel free to email me with any questions or concerns because I love to help my students. Thanks, and hope you have a great day.